Alright guys, so on this video I'm going to talk about symbol notations of real numbers and symbols that you might also find in sets, and it's related to graphs. Okay, so to start with, I'm going to be talking about the integers. So all of the numbers in these sets that I'm going to explain here are going to be integers, so we don't worry about decimals or fractions or even negatives, right, on these examples. But these rules apply for all the real numbers. It also applies for decimals and fractions, okay? So the first symbol that we might encounter in sets or graphs is going to be a bracket. And in set notation, the bracket means that you're going to include whatever number has the bracket. Okay, so if you have a number in a set, let's say it in a set. So for example, if I have a set, this is not a coordinate, okay? This is an interval. So I have from 0 to 5, and I have brackets on those two numbers. If I were to transform this into a set of numbers, I'm going to use the brace, and I'm going to write the list of numbers, so all the way from 0 to 5, because that's what the set says, okay? All the way from 0 to 5. So this is a set notation. If I have something written like 0, 5 with brackets, this is not a coordinate. Again, we're not doing graphs with this number, right? Then that means that the whole set includes all the numbers in between 0 and 5, and also 0 and 5. Okay. The other situation that we might encounter is if we have parentheses. So in set notation or interval notations, or in graphs, when defining domains and ranges, the parentheses means do not include the numbers in the set. Okay, so this is kind of the opposite of the brackets. So for example, if I have, let's just call it the same coordinates, not coordinate, set of numbers, right, from 0 to 5. On this case, what's going to be different is that neither 0 or 5 are going to be part of the set. Okay, they're not part of the set. So if I'm talking about integers, which is the first integer that goes after 0, it's going to be 1. So that's the first number that belongs to the set. 2, 3, and 4. I'm not going to include 5 like in the previous example because I have parentheses on those numbers, right, on 0, and I have parentheses on 5. So those are the first two notations, brackets and parentheses. And guess what? We can also have those combined, right? So we can combine those brackets and parentheses. Parentheses and brackets. Okay. So what this is going to mean is that you have to just follow the rules, right? You keep the rules. So if it has a parenthesis, then it's not included. If it has a bracket, then you have to include it. So same example, but I'm going to put a bracket on the 0, and I'm going to put a parenthesis on the 5. So you can have these combinations, right, of bracket parentheses. And if you were to transform this into a set of numbers, the first number that's included is going to be 0. And how I know this is included? Because it has a bracket, right? And we said that brackets, you have to include that number in the set. Okay, so the first number of this set has to be 0. So 0, and then all the way, everything in between, 1, 2, 3, 4, and I'm not going to include 5. Why? Because the interval notation has a parenthesis, so I'm not going to include 5. And since we're talking about integers, I don't have to include any of the decimals. Okay, so this is what the set will look like. And we can also have the opposite example. I'm just going to call it the opposite example. I have a parenthesis on 0, and I have a bracket on 5. So this combined example means that the set is not going to include 0, because now I have a parenthesis in the 0. Okay, so it starts in 1, 2, 3, 4, and now I'm going to include 5 because this is a bracket. Okay, so I include 5. And this is what the set of numbers is going to look like. Okay, so it's a little bit about the symbol notations for brackets, excuse me, and parentheses. Okay, so the next thing that we're going to talk about is going to be symbols and graphs. Okay, so on the graphs you can find several different symbols, and some of the symbols are going to be closeouts. That's the first example, closeouts. A closeout, it looks like a filled dot, and this means the value is part of the graph. So we can say that this is included. So if you were to relate this close dot to any of the symbols that we just talked about, the symbol that we just talked about that means include in the number set is going to be the bracket. Okay, so that means that if I have a closed dot in a graph, if I were to write the interval notation of that, then that means I have to use brackets. So that's a closed dot. Okay, and remember that if you have a graph that looks like this, just a line, right? I'm going to color code this line. That means that this is a set of closed dots. So every single point on the graph is a closed dot. So all of those points form the line, right? That's an infinite number of points, and all of those are closed dots. Okay, so if you have a straight line, a complete straight line, then that means those are all closed dots that form that line, which means all of the values are included, which means that when you were to write an interval, you have to use the brackets. Okay. And then another situation that you might have is going to be the open dots. You can also have open dots in graphs. An open dot is going to be a circle or a dot that is empty in the middle. And this is the opposite. The value is not part of the graph. It's not included. And since this is the opposite as the brackets, then these values are going to contain a parenthesis. Okay, so again, for example, if I have a graph and I have a line, and the last point of the lines are open dots, that means that whatever value this is on the domain, let's talk about the domain, right? Whatever value that those are not going to be part of the graph. So we will not include those numbers in the set of numbers or in the interval in the set of numbers. Okay, the interval notation of the set of numbers. So these are open dots, they're not included. So open dot you have to relate to parentheses, and closed dot you have to relate to brackets. And another symbol that you're going to find in the graphs is going to be arrows. So you can also find arrows in a graph. And what an arrow is going to mean, well, it looks like this, right? What an arrow is going to mean is that it extends to infinity. So when you have an arrow, that means that if this arrow is horizontal or is pointing towards, it's growing horizontally, then that means that this arrow is going to end up in the infinity, right, or never end. If it extends vertically, then that means it's never going to end. It's going to reach all the way to infinity, the vertical. Okay, so for example, if I have a graph, I'm just going to do 3 examples in here, right? If I have a line that looks like this, then that means that the domain is going to be negative infinity to positive infinity, because this line over here extends all the way from the negative infinity, this keeps extending, right? And it extends all the way to the positive infinity because I have those arrows. If my line were to look like this, then that also extends all the way to the positive infinity on the top and the negative infinity on the bottom, right? So this range will be, this is a range now because it's vertical, right? Extends all the way to the positive and all the way to the negative. And if you have anything in between, let's say that line has a slope, right? That line has a slope. Since this line is increasing horizontally and it's also increasing vertically, then that means that both domain and range are positive infinity to negative infinity, right? Because this line is extending horizontally and it's also extending vertically. So this is how you know that this is going to go all the way to infinity, both vertically and horizontally. Okay, so these are some symbols that you might find in a graph. And now I'm going to explain an example that some of you guys are having trouble with. We have sometimes graphs that look like this. I'm just going to put some marks in here. So it looks like I have a close out in there. And then this is going to go up. This is a graph of a parabola, and I have to define the domain and I have to define the range. So these graphs, they have arrows at the end. Now I think they show in the handout, but you have to assume those are arrows, okay? So those are arrows. So this is a parabola. That means that the parabola is going to extend all the way to the infinity in whichever arrows it has, okay? So it is slowly growing in the domain. It's quickly or exponentially growing in the range towards the top side. Okay, so we want to define what the domain of this function is. I have to look at the ends of the graph, and these are arrows. These two ends are arrows, and they're not vertical; they are parabolic. So that means that they're going to be extending towards the left and right, infinitely, all the way to infinity, and towards the top, all the way to the infinity. Right? These are not extending to the bottom. So these are expanding to left and right. You can think about it as something like this, right? Also, think about it that way. So it's extending and extending and extending, right? So I want to say the domain for this function or this graph. The domain is going to be all the real numbers, okay, from negative infinity to positive infinity, because horizontally, right, this point over here, it has a correspondence in the graph. And if I keep growing those arrows, then this number has a correspondence in the graph, right? There's correspondence in the x-axis. So that's why I know the domain is going to be negative infinity to positive infinity, because these arrows, they can keep growing, right? And over here, I do have a correspondence in the x-axis, right? If these lines keep growing, I do have a correspondence in the x-axis. So there's always a number that's gonna have an outcome in the graph. Okay. Now regarding the range, we want to take a look at the range. Let me get rid of all these notes really quick. How do I find the range of my graph? Well, the domain is going to be the horizontal values that the graph, the available horizontal value that the graph has. Okay, and the range is going to be the vertical values that the graph has. Okay, the available vertical values that the graph has. So in this case, let's talk about the range now, vertical. So it does not extend all the way to infinity towards the bottom. It extends all the way to infinity towards the top. So those lines, those are going to keep extending, and this value of the range is going to keep increasing, right? Assuming that this, it keeps going. So there's 5, that's a 6, this over here, that's a 7, and it's going to keep increasing, right? But what is the lowest value that is part of the graph? There is a lowest value in here. So this lowest value, and since this is a closed dot, that's going to be the last value of the graph, or the lowest value, right? So that's the first one. That's a 2. And the highest value, well, this graph is just going to keep going and going and going and going all the way to infinity. Now we have to decide which symbols we're going to use in this case. Okay, we have two options. So infinity is always going to have a parenthesis, because since infinity is not a real number, this is just a symbol to denote it's never going to end. We're not going to include it in the set. That's why we have always a parenthesis in infinity. But the number 2, we have to choose between a parenthesis and a bracket, either or. It depends on if the number is part of the set or not. So if you go down all the way to the graph, this is the lowest point. And the original graph, it has a closed dot, right? So that closed dot means that this point is part of the graph. If instead of a closed dot, it will look like, I'm just going to make an open dot, then the number will not be included. But since it doesn't, I don't think it shows a closed dot, so it just shows the line, the regular line. So that means that this is a closed dot. So a closed dot is always going to have a bracket. Okay, and maybe that's why you guys were getting this wrong, because one option said that and one option said parentheses. Okay, so you have to be careful. These things mean two completely different stuff. Okay, so make sure that you complete the assignments, complete the quiz, and get ready for the work for the next week.